it is changing and it is increasing. 8.49, 8.52, the reactive power is also increasing. Okay, so what actually it's indicating here? So basically in the inductor basically consume the reactive power. Okay, in the circuit, inductor basically consume the reactive power. So once they consume the reactive power, that's why your real power is increasing here. Okay, so if you just change, you can see that by changing the inductor, the shunt reactor value, you can improve the real power, which is sending end to receiving end. And not only that, just see the value, which is 15.91 now. Once you are changing, the source end voltage is increasing. Okay, source end voltage is increasing. Okay, so in this case, they are talking about that once you are varying the shunt reactor value, you need to analyze the real and reactive power flow and the losses. So this is the basically the real power, reactive power and the apparent power, which is going to the transmission sending end to receiving end. Okay, this is the real power and that is the reactive power, and this is basically the losses. And losses have also real and reactive. Okay, real and reactive losses we have. Okay, so you need to, in your lab reports, okay, in your lab reports you need to analyze like that. I'm converting into the initial stage where the source voltage. First you need to analyze that what in the initial stage, what is all what are the all values, like this is the source voltage, those are the real reactive power of the power from power in sending end to receiving end. Okay, and those are the losses. So what is actually happening here, you need to write down, like is it increasing, is the real power increasing, reactive power increasing. Once your real or reactive, if any power is increasing, your apparent power must be increasing, because like this is the multiplication, complex multiplication, not the normal multiplication. Okay, and this is the losses. Okay, so they are talking about those things like the losses, real and reactive losses. So you need to just change the values and you need to analyze deeply that are they changing in which direction. Okay, so the losses are also increasing here. Okay, so the losses are also increasing, so you need to just write down all those things in your lab reports and you have to analyze. Okay, so there is another thing which is voltage regulation and transmission line efficiency. Okay, in this interface of the PowerWorld, we don't have any scope so far. We don't have any scope to find out the voltage regulation from the PowerWorld interface, but we all know the the formula of the voltage regulation. Okay, what is that basically? The sending end voltage minus receiving end voltage divided by sending end voltage multiply into receiving end voltage, and after that you need, for getting the percentage, you need to multiply into 100. Okay, so this is the voltage regulation. So what you need to do at the initial stage, what is the voltage regulation? First you need to just you can make a table. Okay, that once the reactor value is 00 MVA, what is the source value, I mean the sending end voltage and the receiving end voltage. Okay, and what is the voltage regulation. Okay, so this is the initial stage. Okay, so if I calculate this one 14.98 and 13.8 into hundreds. Okay, so from here the voltage regulation is 118. Okay, in terms of percentage. So once you are changing, it is also changing. So your voltage regulation will be also change. Okay. So this is the basically the voltage regulation formula for the your network. Okay, one more thing is that you can just do for the initial stage, which is source voltage were 14.98 and receiving end is 13.8. You can calculate the voltage regulation, and then once you are changing, like you can change for 0.5, 1, or maybe for the 2. Okay, then just make a small table and just calculate the voltage regulation. Okay, one more thing is the efficiency. Okay, transmission line efficiency basically is that this line, how much this line is basically contributing. Okay, so uh, here the transmission line efficiency is generally the normal formula of the efficiency we have, and also we don't have any scope to see from the PowerWorld here. Okay, so the normal is that the your if we consider the real power. Okay, this is the basically the input power we have. Like if I convert it into the initial stage. Okay, so for this is the real power of the initial stage, and this is the losses. So the efficiency or the transmission line efficiency formula is that input power minus loss divided by input power into 100. Okay, for getting the in terms of percentage. Okay, this is the transmission line efficiency formula. Input power minus loss divided by input power. So once you are changing this, your efficiency value is also changing. So you need to analyze that once you are changing the value of shunt reactor, which is actually the inductor here, what is happening? Is that efficiency increasing or is that decreasing? Okay, so this is the analysis, and the issue is that you have to analyze by your sorry, you have to analyze by your own. Okay, okay, just one more thing, I need to open the recording. Just one more thing. Recording has started by joining. Just wait. Is anyone recording here?
Yeah, recording started already.
Okay, recording started already. Okay, just share me the file once once the recording completes. Okay, so that we can actually do the uh, file to share to the Dr. Faris. Actually, who he wants to see uh, the demonstration. Okay, so kindly share me once the recording is complete. Okay, so thank you to start the recording. Okay, I just forget. Okay, so this is for the task 1. Okay, so this is the task 1. Okay, one more thing is that why shunt reactor is installed at transmission or distribution network. Okay, so basically uh, there is, uh, uh, once you want to control, okay, the control the sending end voltage by changing the shunt reactor value, you can control the sending end voltage. Okay, so uh, one of the scope is that uh, once you are installing the shunt reactor, you can control the sending end voltage, which is the source voltage, and also you can actually control the transmission line here. Okay, so that is one of the issues, that by using this only components, you can control the sending end voltage, and not only the controlling, also you can increase the sending end, which is the source voltage, uh, uh, by using the shunt reactor. Okay, so this is the task 1 we have, and we have very similar task for task 2. Okay, which is also contain 50%. Okay, so what we need to do here, we need to do another file of lab 2 task 2. Okay, so let's see the second file. Okay, okay, can anyone say me that what is the change of this circuit? This is the lab 2 task 2 file. What is the change here?
The load,
Load.
yeah,
Okay, just
from inductor to capacitor.
okay, and the previous one.
Inductor, shunt
In,
reactor.
yeah, the shunt reactor, the inductor. Okay, yes. Here the capacitor, we are using the capacitor. This is the only difference. So now we will see that how, once you have installed the shunt capacitor in your network, what will be the changes. Okay, what will be the changes here? So there should be some changes, because uh, capacitor in capacitor, it will influence the overall network. Now we'll see how it's uh, influence the overall network. Okay, so what we actually need to observe first, see the lab 1. Okay. Okay, so first, very similar, you need to simulate the power flow and also analyze the system parameters in terms of real, reactive power flow, reactive losses, voltage regulation, transmission line. So very much similar, just we are using the capacitor, so the explanation or the changes will be different from the previous one. So let's see. I am seeing the power flow here. Okay, that's good. So power flow is going on from sending end to receiving end here. Okay, so for the positive capacitor, you can't change in the negative direction. You need to use the positive direction. Okay, so just see the changing once you are increasing the value. You see the source voltage is decreasing. Not only the source voltage, the real power, the reactive power is also changing. What about the losses? The losses are increasing. Okay, so what actually here happening? Okay, so basically capacitor in the circuit, capacitor is supplying the reactive power. Okay, so like here we have a load of 8 megawatt and 4 mVA, which is the reactive. So if I just make it similar, 4. Okay, so in the load our requirement is 4 mVA, which is 4 reactive power, and my capacitor is also supplying the 4 megawatt. So this losses of the mVA should be the minimum one. Okay, where you can supply the load requirements. Okay, and your losses will be very low. Okay, so what you actually see from here, you can see that once you are changing the value of the capacitor in positive direction, your source voltage is decreasing, your real power, reactive power is decreasing from sending end to receiving end, and also the losses are, but the losses are increasing. Okay, the losses are increasing. So this is the what called the real and reactive power flow, real and reactive losses, real and reactive losses. So those are the real and reactive losses, and this is the real and reactive power flow. And the voltage regulation, so very similar to the previous one, that where you need to use the formula for different. So what you need to do, that just make it this initial stage 0. So this is the initial stage. You need to make a voltage regulation formula here. Once you are changing and make it to the 4. Okay, you can also change the load mVA. Okay, but I am not changing the load mVA. Okay, so just I am changing the value, the value of capacitor here. So now this mVA and the load mVA requirement is same. Now you can say that yes, that the mVA losses will be the minimum one, and for that reason you can find the voltage regulation also. So for 0 to 4 mVA you can find the voltage regulation. That very similar to the transmission line efficiency. Okay, now why actually we use shunt capacitor here? Okay, so the answer is very much similar. Okay, but basically the shunt capacitor is using for improving the power factor. But for this small network there is no no issues of power factor here. But yes, since it has the issue, but we are not interested in the power factor components here. Okay, but the main issue in the real time is that for improving the power factor. Okay, so you need to write down that yes, for controlling the sending end voltage to receiving end voltage, you can control by the shunt capacitor. And also if you write down the yes, for improving the power factor, you can use the shunt capacitor. This will be also another good reasons. Okay, so this is basically we all have this task 1 and 2. The only change between this task, the analysis, how much analysis you can do here is the main thing. Okay, how like your sending end voltage, your receiving end voltage, the power from sending to receiving, the losses, how much and deep analysis Analysis means you need to write down that yes, it is increasing, it is decreasing. You need to make a comparative study. Okay, the comparative study or the analysis is the main issues, because nothing is actually complicated here. Just need to change the values, but the issue is that how much deep you can mm, make a comparative study here. Okay, so try to make a very deep comparative study so that you can mm, write down in your lab reports. Okay, so okay, all we have about that. Okay, so if you have any questions you can ask me. Okay, then we'll go to the rubric part. Okay, so if you have any questions, let's ask me.
Sir,
Yeah.
during your task one, you set your inductor value to negative. What does it mean by negative inductor value?
Which one? The task one.
Yes.
This. Okay. This one. Yeah. Okay. So what's happened here?
During your simulation, you set your inductor value to negative. But may
Yeah,
I know what
negative.
does it mean by negative value?
Okay. Basically, inductor is basically consume the reactive power. Okay. So in real, or you know, uh, there is no scope. Like if in your simulation, if you want to increase, just try to increase value in the positive direction. You can't. Okay, you can only use the negative direction, because if you change the value in the positive, there will be no then there is no scope we have for the reactor the inductor. Okay, once you are changing the value in the negative direction, there is some uh, you know some changes which is actually like the increasing or the decrease in one, but we can't do it for the positive direction. That and the option is also disabled. Okay, so we can't use, but also you can just similar. If I open the task 2, okay, you can't change the direction of capacitor. Just see, you can change the value of the capacitor here. That is why I am saying that you can only change the value in the positive direction for the capacitor and the negative direction in the inductor. And the real thing is that the reactive power, inductor is basically consume the reactive power, and capacitor is basically supplying the reactive power. So once the inductor is going to the negative direction, it is basically consume the reactive power. It is the basically the fundamental law of the inductor. If it can't go to the positive, and it will supply. If it go to the positive, it will be converted into the capacitor. Okay, because those both are basically generating the reactive power. Okay.
Okay, thank you, sir.
Okay, thank you. Okay, any other questions we have?
Sir,
Yes.
what is the use of the lot beside the inductor and capacitor, since we didn't change the value of it?
Uh, which one?
The one with the arrow, yeah, the right hand side.
This one.
No, I mean beside the capacitor. Yeah,
Beside.
that
Yeah.
one. Yeah, correct. Yeah, right. Yeah. What is the
Okay.
use of it, since we didn't change the value?
This is basically the load. Okay, so the load actually, like if you can see that this is the sending end and this is the receiving end. Okay, so you are providing the power to load, to supply this load. Okay, so this arrows are indicating that the your power is going to the load and it is basically feeding your load. Okay, it is actually feeding your loads. So uh, this arrow, one is the real, indicating the real power, which is like this one, and another is the reactive power. This is one. Okay, so this is basically indicating that your load is feeding from the sending end, because this is the receiving end we have. Okay, so any other questions we have?
So should we change any value of the lot or just leave it like add and 4?
Yeah, you can change. Yes, you can change. Once you are changed, you can also see the value are changing here. Okay, once you are changing, but the issue is that we are trying to fix the load value and trying to change the shunt reactor value, because this is our tasks, because they want to see that once you are changing the value of shunt reactor or the shunt capacitor, what is actually happening to your line, not by using the load, because once you are changing the value of the loads, then also it will change, but this is not our tasks. Our task is all about that once you are changing the shunt reactor, because shunt reactor is the, the components we are talking about. The loads is basically already variable, you can't fix it. Okay, but the shunt reactor has some fundamental law or the fundamental theory which actually influence the network. So what is basically the theory is that once you are changing the value of the capacitor, is basically supplying the reactive power, and once you are changing the value of the capacitor in the positive direction, it is also decreasing the source voltage. Okay, because it is basically supplying the reactive power. So we are interested to changing the value of capacitor or the inductor. We are not interested to changing the value of, the loads one. Okay, but the load is basically we need, because from transmission sending end to receiving end, we are feeding this load. Okay.
Okay, sir.
Okay, thank you. Okay, so do you have any other questions? Okay, if we don't have, uh, then we can start the rubric part. Okay, so this is the lab A3. So okay, yes. Okay, so I'm just closing from my side, and we'll go to the rubric part now. Okay, so the first, basically the task is very easy. Okay, just you need to summarize that what your understanding is. Okay, so the first person is Ling Fanzi. Okay, so just you need to simulate the network and share your screen and just try to discuss what is happening about the real power and the reactive power. Okay, the Ling Fan Z.
Okay,
Yes. Okay. Share your screen.
can you see my screen?
No, okay, it's maybe coming.
Can you see?
Not yet.
Okay. Now, no.
Yeah. Yeah. Now I can see. Yes. Now I can see.
Okay. So this is the task one with inductive load.
Mm-hmm.
When I decrease the value of the inductor, the source voltage will increase and the reactive power will also increase. But the losses will also increase.
Mm-hmm. Okay, so what is happening to the uh, real power? Yeah, and the
In real power is increasing.
increasing.
Mm.
Okay, and what about the source voltage?
Also increasing.
Okay, so basically you are changing the value in the inductor. So can you
Mm.
tell me the what is the fundamental of the inductor? What is actually it's doing here? Like
In
is it uh, consuming or supplying to the network?
is consuming. No,
Uh,
supplying to the net.
Supplying,
No,
consuming.
consuming.
Okay. Okay, thank you. Okay, then okay, thank you for sharing. Okay, the tasks are very much, very easy, but the issue is that you need to make comparative studies. So I'm giving you the full mark, Mr. Lin Nancy. Okay, so next one, yeah, the next one is NG Chang Meng. So just try to find out the voltage regulation and transmission line efficiency for the task 1 uh, by for the initial stage and also for the uh, value of 2 MVA. Okay, oh sorry, this is the task 2. Okay, just let me okay, yes, just evaluate the voltage regulation and transmission line efficiency for initial stage where is the 00 MVA we have, and for the minus 2 for the inductor for the minus 2 value. Okay,
So what do you want me to do again?
okay, you need to calculate the voltage regulation and the transmission line efficiency.
Voltage regulation and the transmission line efficiency.
Efficiency, yes, by using the formulas. Yeah.
Okay. Give me some time to calculate first. For the voltage regulation, it's 96%.
Okay. So is that for the initial stage?
Yes.
And what about the like once you are moving to the inductor value to minus 2 var?
Inductor value.
Minus 2 var, yes.
Yeah. For the inductor value is 93.76%.
Okay, once you are moving to the minus 2 var.
Yeah.
Okay. And this is the voltage regulation.
Yeah.
Okay, what about the transmission line?
Transmission line efficiency. Okay,
Yes.
calculating now.
Okay. Just let us know.
For the inductor, it's 94.2%.
Okay, it's for the it's for the
Transmission line.
yeah, but is it for the zero? I mean the initial stage?
This one is at when load is added.
Because once you are changing the value, it should be changed. So is it, are you calculating for the 0, inductor value
I
0?
I calculated with the value change already.
What the value you have choose?
I choose -2
Minus
MVR.
2. Okay,
Ah.
okay. That's good. Okay, fine, fine. Okay, thank you.
Thank you, sir.
Thank you, Mr. Chengman. Okay, so the next one, I'm giving you 10. So, okay. Ong Lin Young. Okay, the next one is Ong Lin Young. So, just mm, just do the task 2 here. Okay, and try to simulate the power flow and analyze the real and reactive power flow, the losses. Okay, and also tell us about that once your reactive power uh, of the load and the capacitor is same, just like 4 MVA and 4 MVA. What is actually happening here? Okay,
Okay, sir.
okay, just tell us about that.
Sir, can you see my screen?
Maybe it's coming. Yeah, not yet. It's coming.
Is it showing?
No, still not.
Uh, how about now?
Wait, okay. Yes, I can see now.
Okay. So for the shunt capacitor,
Hmm.
when we let me run it. When we increase the value, the source voltage will decrease as shown here, and also when the capacitor is same with the load, the 4 MVAR, its power loss will be at the minimum.
Minimum.
But when we
Loss is
yeah when
minimum.
we yeah true
Okay.
at 4, but when we
Okay.
increase it again, and the relative power will goes towards negative, more negative.
Okay. So basically, what's the uh, fundamental of the capacitor? Is it supplying reactive power or the consuming the reactive power?
It's supplying for capacitor. Capacitor is
Oh,
supplying relative power to the circuit.
okay. Thank you. Okay. Thank you.
Okay.
Thank you. You're only young. So next one is uh, Geoshi Pi. So just
Yes,
tell
sir.
us, yeah, just tell us about the voltage regulation. Just the voltage regulation in two cases. One is that uh, when you have the zero, initial value 0 for the capacitor, and once the value is the 4, which is the load MVA. What is the voltage regulation, and is it increasing or decreasing?
Okay, can you give me a minute? I'll calculate now.
Yeah.
So for the when the capacitor is at 0, so the voltage regulation is 0.57%.
Okay.
And when it's at 4, it is 0.32%. And it's decreasing the voltage regulation.
Okay. So you didn't multiply by 100?
I did multiply by 100.
Oh
You did?
crap!
Sorry?
You did multiply by 100?
I got multiplied by 100.
Okay, so what's the value for the 0 MVA voltage
Zero
regulation? Yes,
0.57%.
0.557.
7.
Okay, it should be like 57 because once you are multiply by hundreds, it should be no, it should be increase because okay, just wait. Just wait. Left 2 plus 2. So like okay, so it once here it's 0. So the voltage regulation is sending end voltage. So sending end voltage is 14.98 minus receiving end, which is 13.8. Okay, then divided by sending end into receiving end. Okay, so once you are going hundreds, okay, yes, it is 0.50%. Okay, so for the voltage regulation, which is the voltage regulation per unit values here, so 0.57, which is for the 0 MVA. So once it is going to the 4, I mean the similar to the load value, what is happening?
The voltage regulation decreases.
Decrease. What the value?
0.32%.
0.32%. Okay, thank you. So actually your value is decreasing means that your losses or the regulation is basically decreasing once your value of the feeder, I mean the loads of the reactive power and the shunt capacitor value, saying the regulation is decreasing, and your losses basically the minimum losses you have. Okay, so thank you.
Thank you.
Thank you, Ju Shupai. Okay, then the next one is Shona Ting Ji Ying. Okay, so just let us know about the transmission line efficiency for the 0 value and the 4. Okay, and let us know, is it increasing or decreasing?
Okay, so for zero initial value, the power loss, the efficiency is 95.01%.
Mm-hmm.
At 4, it's 95.97%. So the efficiency is increasing.
Efficiency is increasing. That's great. Okay, so uh, basically transmission line efficiency is basically increasing means that your feeder reactive value and the capacitor reactive value, once it's same, it is increasing. So it is also good transmission line once you are changing the value. Can you do one more calculation? Once you are changing the value to 5 MVA, I mean the more than one of your needs, then what is happening? Is it increasing or decreasing?
Okay. It should be decreasing, but I'll calculate first.
Okay, I just want to know that how much decreasing or increasing.
So it's 95.91%, which is decreasing as compared to 4 mVAR.
Okay, okay, nice, nice. Yes, this sort of comparative study we actually need. Okay, so the comparative study is always important for your lab reports. So I'm giving you 10. Thank you very much. Okay, so we are very much end of this session. So do you have any question regarding your reports or anything you have? Any questions?
Sir,
Yes.
when we sending the report, should we CC Madam Norailiza and Ajit
Yes.
Masud?
No. I think for this lab too, maybe Hassan Faisal. Okay, kindly check once more that who is the actually in charge of lab 2 for this lab report.
Okay.
Okay, you need to just check the email. There was an email sent by Miss Nuraliza where she mentioned that for 4 labs you where you need to send the reports. Maybe for the lab 2 it's Mr. Alsan Faisal. Just need to check. I don't know because for the lab 1 it was Masood Faisal.
Oh,
Maybe Masood, and
okay.
for the second one it is maybe Asan Bashir. I don't know the name of guy, but maybe it's
Mm-hmm.
Asan Bashir. But before emailing, kindly have a look, or you can just ask Miss Nuraliza that why
Mm-hmm.
we need to send uh, the report.
Okay.
Okay. So okay,
Mm-hmm.
yes. Okay. So any other questions regarding your lab reports? Yes, the lab report should be handwritten, which you have done for your lab 1.
Sir, can you repeat the formula for voltage regulation and efficiency?
Yes. Voltage regulation is the sending end voltage minus receiving end voltage divided by sending end voltage into, multiply receiving end voltage, then into 100% to convert it into the percentage. This is the voltage regulation formula. And the receiving end, the transmission line efficiency formula is that uh, the input power minus loss divided by input power. Then for converting to the percentage, you need to go to the 100, multiply by hundreds.
Okay, okay.
So this is the voltage regulations and uh, the transmission line efficiency. Okay, just you can also mention these formulas in your lab reports, and if you don't mention, I think it will not be issues. Just try to make a table and try to calculate the values for different. It doesn't mean that you just need only 2 or 3 values. Actually, just try to make this, yes, the values are increasing once it is if you can set a parameters like, yeah, for the capacitor I'm choosing like 4 mVA here. So once you are increasing the value of more than 4 mVA, and also once your value is less than 4 mVA, so what is the changing? Is it increasing or decreasing? What types of increasing? And also you can evaluate that how much percentage of increasing just by the subtraction between the change and just into 100%. So you can try to make those uh, the complex analysis, because the lab reports or the experiments is very straightforward. So your lab report should be very comparative. You should have the comparative studies, number one, and you should do some complex analysis. Okay, it will actually give you more confidence for your examinations, for your lab reports, good marks, and also for your the near future. So I think, yeah, you can just try to make some complex analysis, how much complex analysis you can do. Okay, so yeah, do you have any other questions we have? Okay, if we don't have any questions, then we can end the session. Before ending the session, I will take the attendance, so kindly just give me some time to make the attendance. Okay, so where is the attendance? I just forget it. Okay, attendance. So, okay, it's the team. Okay, just wait. I'll take the attendance. Show participants. Okay. Okay, this is group A3. Okay, so I've downloaded the file. So this is for level 2. So I know that too. Oh, yeah. 1, 2, 3. A3. Okay, and one more thing is that you are the person who record the video. Kindly share in the the chat box. Once your video is ready, kindly share it in the chat box so that we can see the videos. Okay.
Okay, the recording will be out a few minutes, I guess. Once it's out.
Yeah, it will take some time, yes. So just share with us so that maybe I can share with the Dr. Faris who actually they in charge of those things. So, okay, so just let me know and kindly share in the chat box. Okay.
Okay.
Okay, guys. Okay, see you.
Okay, thank you, sir.
Okay, thank
Thank
you.
you,
Thank you,
sir.
sir.
Yes, sir.
See.
Thank you, guys. Goodbye.